All right, we're going to update our batching. We did a little bit. We tried to update our batching a little bit earlier today, and we actually good news. Check it out. This is actually pretty exciting. I thought it was a problem. But guess what? It's not. I was thinking that one of our back propagation had some issues where we weren't capturing all the data in the data set, but it turns out we are. It looks like we are actually fully scanning the entire data set completely, and we are ensuring that we're targeting the inputs to the right outputs. It's working the way we want it to, but it's not stochastic. It's not like what we call random, right? It's not random. It's like linear. We're like fully sampling. But you know what? I'm not sure if maybe it does matter a little bit. Maybe I think we should, because sometimes we should update our model, our machine learning framework in general, to support randomized batching. I think we should do that. I think that's a really good idea. We need an even distribution, a smooth randomness. Now we could do this in several ways. I think thinking like creating a range with a range, and then we shuffle the range, and then we pull from the range based on the position of the element in the range. And so we enumerate the range essentially. So here, actually, let's see if we can make it happen. So I do have it. So it is working now. So this is, if we run it now, works perfectly fine. We're in a good working scenario. Oh, I was playing right before stream started. I turned on, I increased the learning rate just to make sure things were looking good. So let's reduce that learning rate just a smidge. Okay, that's looking a little bit better. And we also need to update this because we're using round, but we don't want to use round. We want to use softmax. We want to softmax this. We want to make it a little bit better. Here's where we want to make that better. Because right now it's not. Is it possible? It's possible that one of these will end up being multiples, right? So you can have something in here will be more than one answer. But we just want the one that has the maximum possible answer. And I think that might be coming into the reason why we're seeing some of these red dots on the screen. Some of these red dots you can see here on the screen. You can see some of the red dots. I think that might be some of the problems. So let's see if we can fix that as well. So we've got two things to do this stream. We've got two things to do. I think we can do it. I'm pretty sure we can do it. We can do like a soft max. What we really want, we want the np.max is what we want. We want the maximum value, not a soft max. We don't care about soft max. This is only necessary for training purposes. We're using a sigmoid output because we already know what the activation is going to be in the range. We could softmax on the final output, but I don't think we need to do that. I think we're good. But when we're predicting the results, we want to get the maximum value, not the rounded value. So how do we go about that? We need to, so let's just do Python. Let's do Python here, and then we'll do import let's import numpy as np. I think there's like an np.max, right? This is a function. So if you say like put in an array like 1, 2, 3, 4, and we do something like that, it should give us it gives us 4, but does it give us the position or 4 or just the number 4? It says that the max value is 4. Let's do 5, and let's go over here and say like 10. So, okay, so it does give us the max value of 10, but I want the position. I want the position of the max value. That's what I want. And then we can update it so that way, how do we go about that? How do we get the position of the maximum value? The position of the max value. Let's see if we can Google this. Let's see. Actually, you know what? Let's just do a little bit of Copilot. Let's just use a little Copilot and see what that looks like. Just a smidge of Copilot. Okay, here we go. So max value index. That's what I want. That's exactly what I want. Result max value index. Okay, let's see if this works. I don't know if I like that. Let me see. Oh, argmax. That's what I want. I want argmax. There we go. That's what we're looking for. Argmax. Number 3, right? So 0, 1, 2, 3. So it gives us the third position. Perfect. Hey, Mimulus ringers or ringings. Don't forget the Boolean. Yes, we do have. You're right. We need to get the position, and then we need to like iterate basically through the results for each of the results. So we've got our predictions here. Right, we got our predictions, but it's a multi-dimensional. Sir, let me help you, sir. Absolutely, please help me. Help me out. Chat, feel free. Backseating is acceptable. We like it. It's good. We like the backseating. Happy to help. Please give me your algorithms and I will implement them. I will implement your algorithms. Just let me know what you're thinking. So we want argmax. We like that. Let me see here. Let me turn off Copilot for a second because it's a little bit much. Disable. There we go. All right, Copilot. Now chat is in control. Chat, you're in control. Let me know if you have any algorithms. Otherwise, I'm just going to type as I go. So we do want the argmax. We want the argmax, and we don't. I suppose we could do something like, but basically what we want to do is we could say, so for, how do we want to do this? I suppose we could just add into, I don't want to mutate. Play Minecraft together? Play Minecraft together? That's a good one. Can't you just use ChatGPT? IQ General, we 100% could, and it would give us the answer right away. That would be too easy. What do you have to learn? That would be too easy. It would be too easy. It's for I mean, like super simple, too easy, you know. There we go. Let me let that. All right, too easy. Too easy. You want me to do the easy mode? Is that what you're saying? We should make it easy? No, let's do it hard. Let's do it the hard way. Let's try to figure it out ourselves. It's how you learn. It's the best way to learn, and you remember forever because it like burns into you. You're like, why isn't it working? I don't know. It's not working. And then you're like, and then you figure it out, and then it's very satisfying. It's very satisfying because then you remember forever. You never forget because you went through all the trauma of trying to figure out why it wasn't working in the first place. So that's what we're going to try to do. So we want the argmax. This is good. We want the argmax. So I'm thinking like we could do list comp, right? We could do some list comp for I and so I guess for P for the prediction in what is it? Predictions. These are predictions, actually. We should say predictions. That's what we really should say because it's a bunch of predictions for P and predictions, and then for and then it's going to give us the output, right? And the output looks like this. Where is that? Where is that at? Output. So wait, hold on 1 second. 1 second. We gotta comment some. Actually, you know what? We could just go up. Hi, here we go. See, so the outputs look like this. So it's an array that appears like this. So let me just copy that over here. I like that. There we go. See, okay. So this is what that looks like. So what we want to do is we want to capture that data. So all right. So we say over here we go IP like that. We only need one there, I think, for now. So for P and P, and then we need to go a step further. For I, or I guess for number in P. Can we do that? Yeah, I think we could do this. I think this will work. I think it's just like this. I think this will be fine. Maybe. We'll find out in a moment. We'll find out in a moment. I know it looks a little confusing, doesn't it? I think it looks confusing because now you're like talking for and P and it's a little bit difficult to read, which is not something I typically like in general. How are you so intelligent? IQ General. We're trying our best. We're trying our best. I think that's the answer. Give it the best possible shot. And then you win. And then you win. So, okay. So for N and P and P and in the beginning, so this will be N over here. And then if N, and then we could just copy some of this like np.argmax. And then it'll be np.argmax of P, right? Is equal. Oh, we have to do an enumerate though, right? Because if we want, so we need to create a range. Basically, okay, so we want to create a range, but in the range, we need to set, thank you for the likes, you guys. That's what we want to do, range. All right, there you guys are, you like the idea of range, don't you? The range. The length of P, or I guess the length of N is what we want. So we need this, and so this gives us a range, but the challenge is, what is the ID? Oh, this is Vim. This is Vim. So we go right here. So you see Vim, you can see here, what is it? Wait 1 second. Let me bring that back up. Here we go, Vim. Here we go. Okay, so we've got version 9.1 of VIM, you guys. VIM, thank you for the likes. Hey, Quastianin. Hey, how's it going, Quastianin? See, happy to have you here. Happy to have you here in the stream. Okay, so we got our Vim version 9.1. We're good to go there. All right, close that. Get out of there. Back over here. All right, NP, PyTorch, NumPy or PyTorch for pet projects. This is NumPy. Yep, you know what's going on. This is NumPy right here. We got some NumPy on the screen. Hey, Suri, Bist, how's it going? What are you building today? today we have, so over previous streams, so over the past few streams, we have been successful in building our own deep learning. Thank you for the likes, you guys. Deep learning neural network from scratch. We built it from scratch. We were successful. We did it. You can see all of our algorithms. This is the most important algorithm right here that you see on the screen. You can see right here on the screen. This is where we succeeded. We built it. We did the backward propagation, which was the hardest part. I am so excited that we actually got it to work. And we just made a few updates earlier today. We made a few updates to get some of the parameters, the hyperparameters, into the right spot so it's nice and tidy and clean. And it feels so much better now because we had a whole bunch of things. We were using global variables, which, you don't want global variables, right? Thank you, guys. Thank you for the likes. And so we turned it into parameters instead of global variables, and we did some cleanup on that. So now what we want to do next, this is what we have to do today. This is the plan. We want to get our batch. Congratulations. Thank you. I know it was really cool. I loved it. It was like a breakthrough moment. It was like the most relieving moment ever. It was like, but what if I can't get it to work? What if it doesn't work? And the rule was no AI help. We couldn't get help from the AI or anywhere else. And so we did it and we succeeded. It was so cool. Thank you for the likes, you guys. All right. So now what we have here is we want to do batching. So we added batching right here that you see on the screen. Looks good. It actually covers everything we want, but I want to make an improvement to this. I want to improve the batching. I want it to be randomized, right? You want a stochastic gradient descent, right? Stochastic gradient descent, which is, random training data, right? You you just shuffle the training data. Can you get help from George Hotz? I mean, why not? Why not? We could. I guess let's see who that is real quick. George Hotz. All right, George Hotz. George Hotz. GeoHot is an American. Oh, I remember GeoHot from so long ago. The iOS jailbreaks. Whoa, you remember his full name? I remembered him as like a GeoHot. I remember him as GeoHot. Not George Hotz. I didn't know that. That's crazy. Oh, wow. We're very similar in age as well. This is crazy. What do you know? Yeah, so maybe someday we can get some help from George Hotz. GeoHot. There you go. Okay. So this is our current batching algorithm, which is pretty good. It does pretty good. It covers the ranges. It does pretty good. He does competitive programming. He does. Well, he's definitely the one to do it. He's the one to do it. To make that happen, he'll be the one to do it. Okay, so where was our argmax at? We were making our output look cool. We were making our output look amazing is what we wanted to do. Hey Joshua, thank you for joining. You joined the channel. Thank you. I saw that in the last stream. That was really cool, Joshua Casey. That was awesome. Can you visualize the neural network with all the nodes? Don't know if there's anything to learn from the maps, but it looks cool. It does. And you can. I've done this in the past. So something that I like to visualize is you can do something like you can see how big, use ASCII characters, like a range of ASCII characters for the blocks. So here, let's enable Copilot for a second because it's going to help us do some autocomplete real quick. It'll do some autocomplete. So Copilot enable. So we want a here we go. We're going to do a, what do you call it? Do ASCII blocks descending how do you say descending size. Here we go. So blocks, we'll say blocks equals not that, but although that does look cool. We want it, we don't want it to be colored, non-colored. Let's see if that works better. Yes, something like that. There we go. That's what I'm looking for. Look at that right there. Oh, this is going to be cool. All right, Joshua Casey, now we can do some visualizations. Because what you can do is you can create a range and then you can visualize the data with this approach right here. It's going to be neat. We could totally do that. What is the application for your neural network? We're doing what do you call it? Toy data set. We're doing the MNIST data set. The MNIST dataset. You're familiar with MNIST dataset, which we're loading from TensorFlow because it is easy to import the data that way. They made it really easy for us, and then we're shaping the data so that way it fits into our model. And this is what our model looks like. competitive programming, live streaming it too. That would be amazing. That's something that we should do. Visualize this as an ER flow sheet. Wait. ER flow sheet? Wait, this is something new. I don't know. What is that? What is ER flow sheet? What is this? What is an ER flow? Emergency department flow chart. Is that what that is? Is that what you're talking about? Something like this? I suppose we could, but the problem is there's way too many parameters. It would explode the screen. You wouldn't be able to tell what's going on. You would not be able to tell. Also, currently, just to let you know, this is a lot of parameters right here already. How many parameters is that? Calculator trying to visualize something that is going to be a challenge. It's going to be a challenge. So we say it like this. So 784 times 100, right? That's already 78,000 numbers. How are we going to show that on the screen? Even with the first layer, it's not going to show up on the screen very well. But we could visualize it. So that is something that we could do using this approach. I like this approach. I like that one nice because it can make it look really pretty. No, I meant entity relationship flowchart. Entity relationship flow sheet. Okay, let's try that. So flow sheet. Let's double check. See, Google doesn't like ER flow sheet, but entity relationship flow sheet. Maybe. No, it still likes flowchart sheet. Let's see sheet. It still wants entity relationship flow sheet is a visual representation known as a ERD. Okay. What are we programming here? Jar. We've got our machine learning framework that we wrote from scratch. Completely from scratch. We were successful. And now we're making it pretty. We're making it pretty now. We're making it better. So we've got a couple of tasks today. From Joshua Casey, we want to make some of the outputs look kind of pretty. So we're going to use some descending color blocks like this to make them pretty. And then we also want to capture our predictions and our results better and different than this because we need to capture it in a better way because right now it's not as good as it could be. So that's the idea. Charles Kim. Hey, how's it going, Charles Kim? I just built a GUI. You did graphical user interface with a complete Bible. Really? In a song file? What are you doing? Wait, what's going on here? It searches the chapter and verse. Oh, it works, but I can't get it to an exe. Any pointers? You want to make a binary? Or what you mean JSON? Wait, hold on. Those are two different things. Charles Kim, what are you talking about? That is the most random. All right, so you built a user interface with a complete Bible in a song file. What's a song file? What is a song file? It searches the chapters and verses, and it works, but I can't get it to a JSON. Well, you want to serialize it, I guess. If you want to serialize it to a JSON output, you need to get a JSON parser and then export the data into a JSON format using a serializer. Depends on what language you're using. All right, here we go. Let's see if we can get back to it. So we've got 3 tasks today. So this is a to-do here. So we'll copy this, to-do. And then we got a to-do on this. We want to make it pretty on the output. Make sure you mean JSON, it's a JSON. Wait, what do you mean? A JavaScript object notation. Yes. Well, what about it? What do you mean? Oh, what's the GUI? What is the UI? And then this, gotcha. The song file is JSON. Oh, got it. Okay. Thank you for the likes. We figured it out. We intuited what's going on. Thank you for the hearts there. I appreciate it. Yeah. Okay. So complete Bible in a JSON file. There we go. JSON file and searches chapter verses, but you can't get it into an exe. Well, if you want to, there's a couple of options. So if you want to just take your existing code as is, you could put it into a container like a Docker container, and that way it's portable because you can create the container as an image and then export the image and then give it to anyone, and now they can run and search your code. Charles Kim, yes, there we go. Charles, did you build a Bible citation tool? That's what it is? Charles Kim, cool. Very nice. You got some options there. Okay. So let's see here. Let's see if we can get the max value instead of doing a rounding. Let's see if we can do this first. So we've got the range of the length of n, which is going to give us the value of the prediction. Let's just do this. To make it easier to read, let's just do this. let's do this. And then we'll have our results. Wait, we already have results here. Wait, oh, that's what we're going to do. Okay, yeah. So results equals an empty dictionary. Let's turn off Copilot because it's doing things. Here we go. Copilot's off. You created an AI framework. We did. Jar, we did. You're right. This is it. And so now we're just making it awesome. We're making it awesome. So we have it here on GitHub. And it's really like regression algorithms and all that stuff. It is, yeah. Or what it is, it's basically regression. You're right. It's basically regression, but it's support vector machine, but a step further, it's an artificial neural network, and it's deep learning. So it's a DNN, right? Deep learning or deep neural network is what it is. Is HTML and CSS more difficult than this? Yow ams. No, I'd say HTML and CSS are on the simpler side of things compared to AI, which is, so thank you for the likes, you guys. I think I get what you're saying. Excellent. Good to hear. But yeah, HTML and CSS, easier, definitely easier. The hardest things in computer science, I would say, are, assembly or low-level stuff. Rust, which is a crazy language, but it's amazing, and it's worthwhile, and you should definitely do it. AI is another very challenging thing, and game development. Those things are all the most challenging things you can do in computer science, I'd say. How much time did it take you to do it? We did it in 2 days. Actually, we did it. We did it only in, we made the core of the framework in a couple of hours, basically. Just 2 different streams. We did it live on stream. You can see some of the VODs, some of the video on demands. We did it, you guys. We succeeded. And this is the core of the framework. These 3 methods right here that you see, they're very straightforward. Actually, they're not very straight. I can't say they're straightforward because as you can see, they're only 2 to 3 lines of code each. Isn't that amazing? 2 to 3 lines of code each. The forward pass is super easy. Basically, you take the inputs and you multiply them by another matrix, which is the weights, and then you add another matrix, which is the bias. And then you apply an activation, which I just call the normalization process because it normalizes it across a range. It prevents it from exploding too far because you don't want to explode your weight or your parameters. If they get too big or too small, then you have problems. You have something called exploding gradient or something called vanishing gradient where the model gets so tiny and small at certain areas within the parameters that you can never escape. It's kind of like falling into a black hole where there's no chance you pass the event horizon and there's no returning. No returning unless you destroy everything. So that's what it is. And what kind of architecture you use for this thing? Architecture. This is basic. It's very basic. Standard dense. I guess you call it dense, right? So they're fully connected dense layers. And it just looks like this. So it's very simple. Thank you for the likes, you guys. Gonna go try. I'll let you know. TY. Excellent. All right. Good to hear. So it's just 3 layers, really simple. We could add more like this. Oh, look at that. We added a whole bunch more, but we're not going to do that. We don't need to do that. Let's see here. Okay. Let's see. Let's keep it like that. Thank you for likes, guys. Love this. Helps me a lot. Excellent. Good to hear. All right. Thank you for the hearts, you guys. I like to see those little hearts on the screen. Yow Ams, I heard that in a developing have what we call a black box. Basically, the AI Hive, you got it, the AI Hive, some results that even the developers don't know how it did it. You're right. That's what we're doing. And there's so many parameters here. I think that there's a lot of parameters. We can't really tell what it's doing. We can't. Thank you for all the likes, you guys. It's basically like a whole bunch of if statements all in a row. And there's just, it like tunes all the if statements, and it's like a whole bunch of variables. You kind of think of it like that, just like a million if statements. And it is able to sort of Klinkle block its way through and find the best answer on the other side. It's really neat. They call it the kernel or the kernel operations, where you're basically just doing matrix multiplications. And then you do, for back propagation, you just do the opposite. And you find how wrong the model was. So here you go. So when we do the training part, we do forward pass first. So we first we say here, it's like throwing a test. It's like doing a test with a human. So, hey, human, we're going to give you a test, a piece of paper with a whole bunch of questions, and you have to fill in the answers. So that's what this is. That's the forward pass. It's basically saying, hey, AI, here's my questions. What do you think the answers are? What do you think the answers are? And then the AI gets it wrong. And then you say, how wrong did you get the answers? Because we know what the answers are, which are the targets. And then we know what you predicted. And then we do a delta on that to see how wrong it is. And then we sort of optimize it from there. And we just sort of slowly update the weights and the parameters of the model, which is basically just floating point numbers, right? They're just floating point numbers. All these floating point numbers right around here. Here you go. So we update these numbers on the screen, you see? Very slowly, just a little bit at a time. And then we update them over time, and then they eventually learn, and then they can answer the questions, and they get everything correct. And then you see all these green check marks all over the place. And that's how that works. Absolutely. Finally, worth to watch a stream. Nice content. Absolutely. Happy to help dependent bot. Good to hear. All right, so what we're going to do now is we're going to see if we can get our predictions looking good. And then later here, we're going to update our batching algorithm to make it a little bit more snazzy. We want to add randomization, randomized batching. There we go. Let's randomize the batching. We have to do a couple of things. What they call it in AI or math terms is called gradient. Actually, it's called stochastic gradient descent, like that. Stochastic gradient descent. It sounds fancy. Isn't that a fancy word? Hey, Abdul, welcome on in. Happy to hear you. Happy to have you here. What are we doing, Victor Roman? What are we doing? So we've got ourselves our own machine learning neural network that we wrote from scratch. It's a deep learning model. And here is all the logic. Basically, just a few lines of code. I intentionally optimized it in a way that is very minimal, and it has the maximum full potential of all the existing AI frameworks for the most part, right? For the most part. And it is contained in just a few lines of code. As you can see on the screen, it only takes up half the screen of a very large font, like a very large font. Hi, hey, Ulvis, how's it going? It seems like a neural network. You got it. It is. That's what it is. Dependent bot. That's what this is. We got ourselves a neural network. Thank you for the likes, you guys. Thank you for the likes. Okay. So what we want to do is update we're optimizing some of the things. So we've got our results. We're going to do for P in there. And then we got a range. And then we're going to say what we need to do is capture. So here's P. And inside of each P is a prediction of the actual data, and it looks like this. This is what each prediction looks like this. So it kind of looks like that. So what we were going to do is comment that out. There, copy paste that. Spooky Zikos, how's it going, Spooky Zikos? Yao Ams, the model is basically a black box because there are so many parameters that after a few layers, you can't even know what the information you're extracting from the data to make the choices. You're right. That's why they consider it a black box. We kind of already know really what's going on. We get it. I mean, the math is simple. Look right here. This is what it's doing right here. It's very clear. There's only a few lines of code, so we kind of know what's going on. However, it's just so many parameters. It's just really fuzzy, right? And it's a difficult thing to sort of control. And so what we have to do is come up with all these advanced algorithmic approaches to manipulating the data. And that's what we're kind of doing right now. We're making some adjustments. Jar. So this delta adapts to the main matrix. Yes, the delta. Here we go. So we say, hey, what AI model? What do you think the answer is to question A? And then it answers what the question A is. And then we already know what the actual answer is. And we say, okay, it's very wrong. And we get the delta. And then what we do is we send it to the backward propagation. At that point, we create sort of what's called, a gradient matrix, which is going to help update the weights. And then takes how wrong the model is and then applies just a little bit of adjustment. You see here at the bottom, the optimize, which basically just means improve. It's going to improve it ever so slightly, just a little bit, just a smidgen, a little bit at a time. And then it does that in a loop for a long time, and it kind of looks really cool when it works. So yeah, so you need to train it with complete data set for, yes, you have to give it data that it's going to be able to learn from. You're right, Joshua Casey. It has to be data that it's going to learn from. So what we could show you here is a kind of cost function. The cost function is like the loss function. It's very similar. And actually, my loss is the cost, because what we're doing is we're calculating, this actually is the cost. This is the cost right here. So the cost is like the total, the loss can be for an individual item, but then when you average across all of the individual items, like this, what we're doing here is mean squared error, is basically the cost. How far the model is wrong is basically the idea. How far the model is wrong. You can't even know what, okay, so the delta adapts to the main matrix closer to the average behavior of the data. Yes, Jar, you're totally right. To the average of the data that we give it. That's how it guesses or predicts. No, you're right. You're totally right. Not sure how this is working. Jar, you got it right. You figured it out. You figured it out. It's all about averaging. It's all about averaging, because you want to create a model that has a generalized algorithm, right? You want to sort of give it so it gets the best. You can't, because you can make a mistake by training it too much. You can train the model too much, and it'll get perfect answers for everything it's ever seen, but you've trained it too much, so it doesn't have any more generalized parameters to be able to predict something that's never seen before. So it'll give you very bad outputs for data, which means a poor performing model. And that's one of the reasons why you separate your training data from your testing data. You want to have separate testing data that the model has never seen before, and then you can test it to see how good it is. That's how you tell. That's how you tell, you guys. Let me double check. Based on your knowledge as AI developer, do you think that AI will be conscious? Oh, will it be conscious, you guys? It's not yet conscious. It's not yet conscious because it doesn't have any desires or ambitions or drives or aspirations. It doesn't have any of those things right now. It just is a pattern repeater. So all the AI that we have today that exists right now, at least that's publicly available, are pattern repeaters. They are trained on all the patterns that are possible that we can give them, these large language models, right? Or the diffusion models that make images pretty images in videos. They've been trained on all data that we have for existing patterns, and then they can take that and then create new patterns that are based on old patterns that they've seen. So they're not intelligent, they're just pattern matchers. They're pattern repeaters, you guys. Pattern repeaters, and they're very good. They're very good. Or will it be so sophisticated to appear conscious just as automatic? I'm not sure, but the answer is 2028 was the prediction. So we've got 2 years or so. 2 years, 2 to 3 years. And then we're there, you guys. 2028. I'm new, but don't you train, validate, and then test? Train, validate, and then test. Yes. That's basically, you can do that as well. So this is what we're doing. We're doing validation right now. Validation is the process of testing it on things that it's already seen. So let's type it out. Okay, so train, right? You train equals model learns on training set, and then you validate equals model. You're testing test model on training set, so you can see how good it retained the information that you taught it. And then you've got test equals test model on data it has never seen before. And there you go. And that's the multiple phases. That's how it works. Multiple phases, you guys. Yo, Ugo, how's it going? Thank you. Welcome in. Yep, overfitting, Rahul. That is a possibility. You can train it too much. And if you train it too much, then you call it overfitting. It's overfitting, you guys. And then underfitting is when you don't train it enough or you don't have enough data. They are loud and obnoxious. They like music and rhythms. They are a fraction of the population and commit half of the crime. Who are they? Oh, you've got a riddle. I don't know. I don't know the answer to that. I actually don't know, but I know the AI would know. Kind of like a Monte Carlo simulation. It actually kind of is. It's the game of life, you guys. The game of life. Spooky Zictos. Just noticed that you have live subtitles. What are you using for this? I've got your answer, Spooky. Check it out, Spooky. Here we go. Just Google for this. Twitch OBS subtitles. And then you'll come across here. Check this out. Click this button, and it's some technologies that I created 7 years ago. Look on the screen. You can see right here. Isn't that cool? I'm going to zoom in on this so you can see a little bit. There you go. There you go. You can see it's the technology of the future. Right there, you've got some live subtitles. And what I did was I updated it so that way you get one word at a time instead of a whole bunch like that all at once. And it's for free. It's for free forever. And you just, you see here, I think is there a link somewhere? Is there a link? I don't know. Is there a link? It's got to be a link around here somewhere. But this tells you how to do it. You just go to this page and you're good to go. So this is the link. Actually, here we go. This is the actual repository. Thank you guys for the likes. Wait. Oh, not that. Here we go. We want Twitch OBS subtitles. Just Google for this, and then look for the GitHub, and you'll see. Here we go. This is something I created 7 years ago. Look at this, 7 years ago, you guys. Crazy, isn't it? I know. Hey, Cakes. Hey, David. How's it going, David? I'll just call you David. How's it going? Ro, thank you. I'm new to quantitative finance. Oh, using machine learning, quantitative finance. Now we're going, Raul. You can create some really cool stuff. In fact, I could even use this model to do some really cool stuff. So what we do is in our business, we have conversations with prospects, and we record those conversations for quality purposes and assurances, right? And then what we do is we capture that data, and then we can run it through machine learning models, you guys. Machine learning models that we created ourselves to learn insights to improve our products. We have a full gamut. We have thousands of hours of recorded conversations for quality purposes and assurances. Bert, sup, girls and gamers? How's it going? Bert? Just subscribe from Australia. Excellent. Ro, thank you so much, and thank you for the likes, you guys. Happy to have you here. Excellent. Thank you for subscribing. This is so cool. Appreciate all the likes, everyone. Okay, here, let's see here. Let's get back to our thing. See if we, AA Codes. What's up, AA Code? Hello, Steven. I'm new to your channel. I'm currently a senior studying economics at school. That's a really great degree. Economics is fantastic. I recently fell in love with programming, and I want to pursue a career in it. But it's too late to switch now. No, it's not. It's never too late to switch. It's never too late. Major, what should I do or study to learn and land a job? You keep your economics degree. I think that's a really good one. And then you can study computer science on your own. So computer science, when you're learning your software engineering, data science, and your data structures and algorithms, you don't actually need to go to school for that. It's one of the few disciplines in expertise that you never have to go to school to learn because it's completely free and on the internet. And guess what? The AIs, the Chat GPTs, Claude Code, Codex, Gemini, you name it, all of these code generators, they'll do the work for you. All you need to do is just learn a little bit every day and you're good to go. AA Codes. You're good to go. It's good to get your economics degree. Don't worry about switching. You can still learn. You do not need to get another degree for computer science. That's it. You don't have to. It's one of the few degrees that you just don't need. Going great. Just got off work. Happy Friday, y'all. Bert, excellent. Thank you. Getting an entry-level CS job. Ooh, that's some challenge there. Bert, heard that's some challenge, but keep trying. Keep going. It's a numbers game. Hey, Steven, I'm a CS student and love AI. That's great to hear. I love AI too. It's actually my favorite thing. I'm just fascinated with it. And there's so much opportunity right now. Here's why. All the industry across all the world has existed. These software applications that are currently driving all of the economy today are enterprise applications that are driving the economy. They are essentially at this point legacy, but we rely on them heavily and almost completely. Without them, we would not be where we are today. So every business is currently operating on this old technology that works very well and it does a good job. AI is going to take us to the next level. So for the next 10 to 15 years, AI will be used to replace all that existing software. We have many years. We have got 2 decades even of AI that we got to replace. So we need engineers to help us with that, you guys. We need engineers. Thank you for the likes. There we go. That's the future, everyone. Did computing as a postgrad, and now you're working as a software dev. GDB T0623. Excellent. You're on the right path. It sounds like you're doing good. Raul, I get confused around whether linear regression model or using multiple random tree models is the best way to go when training a model to optimize for greater profits. Oh, I found the best model is a support vector machine. If you're doing SVM, I like SVM. It's actually really good, and you can use scikit-learn to do that using SVM and scikit-learn for your, and it works. You can run it with spreadsheet data. You can provide it any input variables that you want, and it will take care of it for you. It's actually really good. I love it. It's one of my favorites. Use that one if you want to have it predict good outcomes. So say you have a bunch of training data, like sales data, for example. You might have a whole bunch of sales data where you have parameters based on the companies, and you have whether the sales deal closed successfully, like it was a good deal. You closed it, you made a lot of money. You can do some predictions. You can do some predictions, everyone. I still have the subtitles running on this tab. I was like, what's going on? I still have the subtitles over here. You can use the support vector machine and the algorithm in scikit-learn. It's a different. So here we go. Scikit-learn. Here we go. This is it. And then you want support vector machines. Where is this? Where is it? SVM is what we want. SVM. Here we go. This is it. Here we go. SVM. Excellent. Now use this, and you can use it to do predictions on sales data to get outputs of predictions on the golden ladder. Everyone, is called the golden ladder. You can make predictions on the golden ladder, everyone. It's really cool. Ro, by the way, sped on and graduated Bachelor's of Commerce, majoring in management and or managing information systems. Oh, cool. 1st February last year. Now I'm trying to teach myself Python and quant finance. Excellent, Raul. Very cool. You want some excellent algorithms there. I love it. Reinforcement learning is really fun too. It is. I love it. I love that too. Work with some awful. Oh no, Bert. Bert, I missed your message. You say you work with some awful programmers. Please don't stop at surface syntax understanding. Oh, we won't. We'll go as deep as you want, Bert. We'll go as deep as you want to go. What is SVM? Support zero regrets. Zero regrets. That's a cool name you got there. It's a support vector machine. It's basically like a regular neural network. It's like a multi-dimensional artificial neural network. It's basically the simplest one, and it makes it easy for you. So all this advanced stuff that we're doing here, the advanced stuff, this is the super duper advanced version of a support vector machine. The advanced version of a support vector machine looks like this. Underneath, this is the algorithm for a super advanced support vector machine. The problem, though, is it requires this particular algorithm. It requires you to sanitize your data before you import it. But with the support vector machine, with scikit-learn, you don't have to do that as much. It will take care of that for you. So it's a little bit easier. And it will get you really good results. It gets you really good results, everyone. John Moan, I took a sales data from multi-stores, multi-product, and I trained a transformer model. Ooh, 70, 15, 15 split. Okay, split and got some RMSE of 89 and MAPE of 280%. Is it bad or worth using? 89%? So if the output, so actually that's a really good question. The output, if you can do predictions and you get the predictions right and it's better than 50%, you're already on the right track, right? Because 50% is random, right? 50% is completely random. It's like it'll be something or it won't be something. But if you get better at predicting and you get really close to like the 90% range, you're already providing value. I think that's a really good progress you've made there, John. Really good progress. Oh, Casey, how is support vector machine compared to a transformer model? Okay, so transformer is going to be similar to this algorithm right here because it's going to be running this kind of algorithm, and it's also going to be transformers typically are about self-attention. Right? So it's going to have a very different input. So when I'm inputting data here, you can see how I'm manipulating the data. right here, I'm doing some reshaping of the data, and then I'm dividing it by 255. This is a really simple version of manipulating the data into a certain format, but it's not fully self-attending to itself. It's not like full self-attention. I would need to multiply itself with itself, self-attention, to create a different matrix, a different shape of a matrix. And then I use that as a vision. It's like a vision, and you're visualizing the input of the relationships between each of the different data dimensions. And then you can put it through a feed-forward network like this. So transformer is going to have extra steps. It's just extra steps, you guys. That's what it is. Support vector regression helps a ton with data that has outliers. Bruce, good idea. Good idea. So maybe SVR. You might want to do an SVR instead of SVL. Support vector R. SVR. Support vector machine with a regression. There you go. You might want to do that version. Or you want to do classification. So regression for number output, if you want to predict like how valuable a certain business is going to be, like what's the dollar value of this business? The regression, it's going to give you money output. Or you could classify it, and the classification will give you like, is it going to close the deal or not close the deal, right? Are you going to close it or not close it? So classification is going to give you like a Boolean or a set of options, and then regression is going to give you a numeric output. A numeric output. Let's see here. Finally, something useful. I know, green, isn't it? You can do so many cool things with technology. My mom says hi. You sound very smart. Thank you, Warren Arnold. Whiz boy, happy to hear it. That sounds so cool. Very nice. Hello. SGD is the godfather algo of AI. Yep, stochastic gradient descent. You know what, Aziz? It is. It is my favorite of all of them. It works so well. It's like a universal algorithm. It just happens to work amazing. It works amazingly. It works so good. And it's a multi-purpose algorithm, and it works on just about everything. I spent 5 years tuning and searching for that specific algorithm, and it turns out of all the different approaches you can take, SGD is the way to go. Stochastic gradient descent. And that's what we're trying to do here. That's what we're going to do. We're going to update this model. So right now we're not randomizing it, but we want to. We want to get the stochastic guy part of, we got to get I think I should try Vim. It's really cool. It is spooky. Vim is my favorite editor. Pretty cool and efficient. Once you learn the commands, it is. The Vim motions. Yeah, you can jump around. You can go to top of the screen, the bottom of the screen. You can go to all. You can do everything. It's great. I love it. It's so good. Let's see here. Wait, what do we do? Oh, here we go. Okay, here we go. Now we're on track. Now we're on the right track. Back to normal. Okay. And the text, image, or video, how do you train ABD is more complex. It is a bit because you want to add, how do you want the data to go into your model? Thank you for the likes, you guys. How do you want the data to go inside the model? That's the part of the picture. You need to add different kinds of layers that help analyze further, like an image. If you're going to do classification, you might want to use a convolutional neural network, which has the ideas of different kinds of layers. So you see how we have a layer here? But with a CNN, you have another layer above that, another set of layers that look kind of like this, but they have a very specific shape, and they're called filters. And typically you have a lot of filters, and they apply based on a matrix. And so it basically lets the AI see. You want to give these layers a vision, some sort of vision, so it can understand. And what you want to do is give it enough vision layer filters so it can start recognizing patterns like a circle, or a square, or a person's face, right? So a CNN will do that for you. A CNN will do that. That's what you want a CNN for. Let's see here. Let's grab that back. Okay. All right. I can never figure out whether to drop nans or not in numbers. Yeah, you definitely want to drop nans. If you can, you'd have to. Or infinities. Nans or infinities, you kind of have to. You kind of have to say they're zeros or something. You kind of have to, I think. You drop the not in numbers and the infinities. Use average. Average would be good too. From the last price, etc. It gets confusing. It does, Rahul. That's a good. Hey, Brentas. Brentas. How's it going, Brentas? How to know what variables or features used for prediction is the best one? You can use something called correlation coefficient, Raul. Or not Raul, Brantis. Brantis. All right, so at Brantis, you want to use something called correlation. Wait, how do you spell that? Is it correlation? Nope, no, you gotta spell it properly. Maybe it's correlation, right? With an E. Yes, correlation. Nope. Here, let's spell it right. Correlation coefficient. You want to do a correlation coefficient matrix. And this is what it looks like. Here we go. Correlation coefficient matrix. Oh, no. Let's go back. Let's get it. We'll just zoom in on this. Here we go. It looks like this. Correlation coefficient matrix. So you've got all of your data, and you're going to relate all of the data to each other. And then you're going to figure out, based on like how hot the data looks with each other. And this is also the idea behind a transformer, you guys. This is like the transformer making its own correlation coefficients all at once. So you can build it into your model, have your own model, decide what are the best parameters using a correlation coefficient layer all at once, or if you want to be efficient, you can do that ahead of time and run it once. So you've got all of your training parameters here, right? All of your training parameters, all of your inputs and your outputs as well if you want, and then you can multiply them by each other, and then you can see how they relate. And then you can see where the red spots are, and then you can drop all the blue spots, basically. Drop all the blue spots, you guys. That is one approach to optimizing your data input when you're training your AI. That is the one way to do it. Correlation coefficient matrix. Opinions on Lua is a microwave Capri Sun. How's it going, Capri Sun? I remember drinking some beverages like that you're still around too. There's still lots of Capri Suns. Lua is fantastic. It's an ECMAScript-like language, and it is used as a scripting language because it's so fast. In most game engines, it's used as a scripting language to improve the game and make it easier to maintain. And also, it's used as a embedded for IoT devices, for microprocessors, because it's so efficient. Lua is the way to go. Lua is a fantastic language. We use Lua a lot. We use a lot of Lua. Ton of Lua. SGG is a magic tool, so simple and powerful. Yep. It's a gift. You got it. It's a gift. We did it. All right, let me see if I missed any of the messages. Sorry if I missed any messages, guys. How to know what variables. Okay, so we did the correlation coefficient. Your greater than 50% advice is classification task, right? Even if it's not classification, if you're doing a sort of a value output in a linear output, you can still get better than you can do a range value task, measuring classification confidence. My case was regression, where you got a mean or an absolute error of 89. Yeah, so that does sound good. I'm not sure if our MSE, I need to see, is it good? I mean, it sounds like it's good. It sounds good, right? Absolute mean error. 89, absolute mean error. Well, if you're doing a mean error and you're getting 89, it needs to be below 0, right? If you're doing error, it needs to be below 0. So 89 sounds like it's way too high in some cases. Like, it really depends. I would need to see what your output looks like. Hi, remember me? Oh, Charisma University. Hi, you do. You've got more passion about this than my coffee got caffeine. Thank you, Charisma University. Appreciate it. Correlation. Oh, with 2 R's. Thank you, Raul. Got to spell it properly. Correlation coefficient. There we go. I'm currently trying to fine-tune a T5. Ooh, sequence to sequence. T5. Wow. That is a very old model for a text-to-text task. Main problem is I don't have enough data. Any methods to address, you have to create your own data. Thank you for the likes, you guys. Thank you for the likes. You have to, Sahin, you have to create your own data. Data problem in Transformer. You need to create synthetic data. It's actually totally fine. You can create some synthetic data. You can do that a lot of different ways. You can you can ask the AI, right? The chat GPT, you can ask the chat GPT to give you some training data. That'll help you. And then you can give it the training data that you have now and ask it to create more similar types of data. And now what you've done is you've created a larger data set. And now your AI that you're training on your sequence to sequence model, whoa, we got some cash money from Joshua Casey. Here's a coffee. Thank you, Joshua Casey. I appreciate it. That's so wonderful. Well, check that out, Joshua Casey. Thank you. At Joshua, wait, let's make sure we do this right. Wait, can we do that? Can we do thank you. Here we go. And then we do thank you, exclamation point. And then we do like a party popper. Let's do a party popper. And then maybe another party popper, right? And then we do like a third party popper. Thank you, Joshua Casey. That is amazing. That will definitely cover some coffee, you guys. That is really cool. Joshua Casey, this is great. I appreciate it. Your support. You're supporting the channel. That's so cool. I appreciate it. That is so amazing. Thank you, Joshua. Oh, that is like a really good, that is like positive happiness. So you go, you made my Friday. Thank you, Joshua Casey. Thank you so much. Thank you for the advice, AA Codes. So how should I structure my resume for the best chance at landing an entry-level job at econ degree? Oh, and does having a big project portfolio matter that much? It is good to have a project portfolio. So it is good. So it would be good to start getting something like that. Definitely do that. And then have it host it publicly somewhere. So you can have it publicly hosted. That is very helpful. And then you can say what algorithm you basically are just demonstrating the knowledge that you have when you do that. It doesn't need to be super big, but the bigger it is, the better chance you have. That's for sure. That's one of the major aspects. Can you show us how to build tab transformer and FT transformer model? I actually don't know. I don't know what are those things? I know what a transformer is, but what are tab transformers? What is a tab transformer? Let's find out really quick. What is a tab transformer model? What is that? What is this? Tab transformer, a deep learning model for tabular data. Oh, that adopts transformer architecture to capture relationships between features. It works by first embedding categorical features into vectors. Then transformer blocks with a self-attention mechanism to create contextual embeddings that are aware of features. Finally, which is this is the correlation coefficients right here. That's the correlation coefficient, the self-attention mechanism, which is a fancy term for just matrix multiplication with the existing data, multiplying by your self input. It sounds like it's fancy, but it's actually pretty simple. These contextual embeddings are combined with numerical features and passed through a feed-forward neural network. Okay, so this is just a tab transformer is just a little bit extra processing before you throw it into a transformer, which actually makes a lot of sense. It's basically a way to vectorize tabular data. Thank you for the likes, you guys. Thank you for the heart icons. And Joshua, again, thank you so much for the $5. That was so cool. That was amazing. Let's see here. What is FT transformer? Let's double check that. FT transformer. What is that? FT transformer is, what is this? Oh, it's for tabular data as well. Okay. They're the same thing. So it's basically your embedding is going to be different. So see, here's a transformer, and then you do your embedding just differently because you're not going to do word level embedding, right? It's not a word token embedding. You need to create your own kind of embedding with a different kind of feature token. So this is, I guess that's what FT is, feature token? A feature tokenizer. There you go. Okay. So actually, that is actually not too complicated. It looks fairly simple. I thought this would be complex, but it looks fairly simple. There you go. I hope that helps a little bit. We won't have time to go through to build something like that, but at least we talked through it a little bit. Rahul, top Kaggle winners in teams use various models and averages them out. Oh, that's really smart. That's a really good idea. So you can create a whole bunch of models with a whole bunch of different hyperparameters, and then you train them like 25 different models, and then you can get the answers from all those models. You can get the answers from all the models, and then you can average their outputs. That's really smart. That's a clever idea. And then you can get the best. Basically, you're creating a consensus. You've got 25 individual people or like AIs. They're all able to give you different answers, and then you pick the best one. The one that's really cool. I like it. Are you looking for interns? Aziz, we used to have interns. We used to do internships. We just kind of slowed down since, 2020. We've slowed down on internships. But maybe learning a lot, dude. Cool. Joshua Casey, happy to hear. You make these subjects interesting. Happy to hear. That's really good feedback. We will keep doing it. That's the plan. We will continue to talk about AI. We're also going to do other algorithms. We're going to do cryptography here. We're going to do some cryptography coming up. We'll even make our own game someday. I think that'll be a lot of fun. That's what I wanted to be when I was growing up, a game developer. I wanted to be a game developer. But then it turns out that enterprise has a little bit more fascinating things when it comes to making business. There's a lot of opportunity from a revenue perspective. So that's where I got into that. But yeah, happy to help, Casey. We've got a lot of tech conversations coming up here. Charisma, bro, I was scrolling through the I came across your live, successfully moved from a tamper monkey. Oh, you did the tamper monkey dependent script to a standalone script. Congratulations. That was like last week or was it earlier this week? It was several streams ago. You got it from a standalone script. That's so cool. Asked GPT to help and it made it, but I'm 5, but okay. It taught me like I was 10. It did. Well, hey, there you go. That's one way to go about it. It helps you a lot. I think it does a really good job. AI keeps teaching like we're 10. I loved your comment. I know. PyTorch versus TensorFlow. Okay, PyTorch. So here's the deal. Aziz, if you want easy mode, you want Keras TensorFlow. All right, easy mode is Keras TensorFlow with Python. You want Keras with Python and TensorFlow. That's easy mode. If you want something that's more advanced and something that OpenAI uses and the most of the world uses PyTorch, right? Most of the world uses PyTorch. PyTorch is a little bit more advanced. It requires you to do a little bit more work, but it has the most flexibility and you can do the most. Basically, it also has a transformer, but they both have transformers. So PyTorch transformer. There you go. PyTorch transformer. And there you go. You can do a transformer here. And just like we were talking about earlier, if you want to do a TF transformer, or FT transformer, you could do it like this. You would implement it using the transformer that you get here from PyTorch. There you go. That's the answer. So definitely between the two, Keras and TensorFlow, really easy. The godfather of large language models said PyTorch is supreme. Yeah, it is. That's right. It is. PyTorch is the way to go. I really like your content. R7 Riz, thank you so much. Yes, that's the answer I want to hear. I already learned it. Excellent. Cool, Aziz. That's great. That's great news. That's great. So we are all in agreement. That's so cool. All right, here we go, you guys. We're actually getting to some coding now. All right, let's see if we can actually get something done. We probably could get something done. Okay, so this is something to do for later. We can visualize with ASCII blocks. We can do we want to do an argmax on the length, so we know. So we do for I, so I in, so we argmax, np to argmax. We'll see. We want to do something like this. What operating system do you use? I just bought my laptop back to life by installing Omarchy, the Arch Linux, the really good Arch Linux distro. Omarchy is fantastic. It's going to, Raul, good choice. I'm running on Mac OS right now. This is Mac OS. We're running Mac OS. Thanks, Raul. Love from my corner of the world. Excellent, bro. You got fantastic energy, Aziz. Thank you. Thank you so much. Let's see if we can get our code going here. All right. So we've got our results. We want to do a result.push, or I guess append in Python, right? And then we need to append the result for I in range. Nope, we got to be careful with that. Something like this, right? How do we do this? Not like that. So that we're going to make it work. We just need to get the predictions to work. Charisma University and Sum Your Way. Blum, you're the plum of the light and the end of the dark tunnel. Rainbow, thank you. Thank you, Charisma. Charisma University. That is so cool to hear. I appreciate it. Thank you for the likes, you guys. Thank you for the little heart icons that show up there on the screen. I thank you so much. Thank you. So what we have to do here is we need to get this. We're almost good with this. We need the argmax so we can find the actual max value. because here's what it looks like. So if we do round, it looks like this, which looks good, but it might be missing stuff. So, but what it really is, it looks like this, and we want to get the biggest value. We want the biggest value in this. So we want the argmax. That's what we want. That's what we're trying to do. Flask guy, what are you? Oh wait, Raul, first time here. I found my people. You did. You found the people. This is where we're at. You found them. Everyone is here. We're all here in chat. Flask guy, what are we trying to do? We're trying to do something kind of simple. What we want to do is find the max value in an array, in a batch of predictions. Is there a community somewhere? Yes. Can you join, Raul? Absolutely. Let's do it. Or we got a Discord right here. We've got a Discord on general chat. Here we go. I will paste in the Discord link right for you. Here we go. This is where we're at. We're in Discord, you guys. We're in Discord. That's where the community is. That's where we're at, in the Discord. Join the Discord, you guys. There's the link to the Discord. Oh, there you are. You joined. Here we go. We got to join. We got someone, Eduardo Orsi. Eduardo Orsi. Welcome on in. Eduardo. All right, let's see if we got here. What do we got here? Okay, let's see if we can make this work. So we got for all the predictions, for I in range of P. Let's see here. Oh, wait, nope. Let's see. What are we doing? Oh, right. Let's see. Let's get this going here. For someone who wants to learn artificial intelligence coding from scratch, what is your advice? Oh, okay. Start with a feed-forward network or neural network. Just feed-forward, something like this. And then maybe even doing like a simple regression model first. And then you can go a step further with a support vector machine. And then go a step further with a deep learning neural network. I think that's a good progress. And that's what we did here. That's what we did live on stream. So last week maybe, or earlier this week, I can't remember now. Oh, it was a blur. We were successful. This is right here. This is like the main code that you need to learn your own AI. This code right here that you see on the screen, this is the master code. The codes that make it good. The code that makes your AI actually work. Right here. I won't let any copy. I'm determined. Excellent, Rahul. You'll make it. It'll work. You'll get there. Thanks, liking this community. Excellent, dependent bot. Glad to hear. R7, where can I teach myself these from? So YouTube is a really good starting point. See if we've looked for some, like, just start simple. Do like from the very beginning, and then you just do Python, and then you're probably going to be using NumPy because it makes it easier. You want to start with NumPy. It makes it a lot easier to do simple things. So otherwise, you'll have a lot of for loops. And then it will get confusing. But this is a lot easier to read right here. Like this line right here is basically 3 or 4 for loops, but all in one line. It makes it simple. But yeah, YouTube is the resource, you guys. YouTube's the resource. Okay, let's see here. Let's see if we can actually get this. All right, so I need your help, chat. Let me know if you have any ideas. So we've got our predictions. Each prediction looks like this. For I in the predictions, here we go. There we go. We want to append. We'll append. All right, so it'll be sort of 0, or if argmax. Here we go. Argmax. Is it P? Is it P? It's P. Argmax P. But what we want to do is the max. We want to say max equals this, so we don't have to recalculate it every time. So max V is what we'll call it, or max P. Maybe we'll just call it max P. Max P is equal to I. Then it. So if. Wait, let's see this. Wait. We'll figure this out. Yeah. Oh, so 0. Oh, no. I like this better. Check this out. We'll do this. If this, then 1. Else, we do 0. There we go. All right. I think we did it. What's going on, Randy? Randy, what's going on? Hey, welcome on into the stream. Okay. We are making our output look nicer. So here's our output. We want to capture the argmax, which we did here. So we got our predictions. We're going to results. And then we need to append this. So this is a list comp. There we go. A list comp. So for range, so we're going to create another range and we're going to append this here. I think I think maybe we did it. Did we do it, you guys? Is this it? Did we do it? Is this it right here? Is this how we want to make it look? So all we have to do is print the results. Is that what we do? Did we make it work? I'm curious. I'm super curious. Let's see if we got. Hold on. We got some code around here that's not liking it. Or that is on line 60. Let's go. But we're right here, line 60. Oh, I forgot probably to close. I've got some things happening here. No, that looks good. That looks fine. What's going on? Lauren. Hey, how's it going, Lauren? Highfield. What are you doing? What are we doing? So we wrote from scratch using NumPy, our own deep learning framework from scratch. Live on stream, we succeeded. So what we're doing right now is we're just capturing the output to make it pretty. We're capturing the output to make it pretty, and that's what we're doing. That's what we're doing right now. Okay. Wait, let's see. Blah, blah, blah. Yes. Oh, okay. Okay. Wait, I see. One, if, there we go. Else, 0. All right. So is it good now? Yes, we did it. Okay, cool. Check it out. Oh, is it going to be pretty? Oh, no, wait, we screwed it up. Results is not, I got to spell. I have spelling issues, you guys. I have spelling issues. I like to copy and paste. Line 60. As it says, line 60. Let's just copy this really quick so we find it. This is misspelled. All right, / there. Copy. Okay. Results. Oh, see, it's wrong by a letter. Results. There we go. Results with an S. That's what's wrong. Temporal difference or MC method. Temporal difference or MC method. It is. If this is what you're asking on how we're doing our back propagation, Lauren, are you asking how we're doing our back propagation? It's very simple. A very simple approach. Is linear algebra used a lot in coding? Well, it kind of is, but also not. So Peter, linear algebra is mostly used in maybe data science and artificial intelligence. In our artificial intelligence, data science and artificial intelligence. But Peter, outside of that, it's barely not used at all. Outside of those two disciplines, maybe some, other sciences and algorithms, you mostly in industry don't use much math at all. Most code is not math, but AI and data science and some other sciences are definitely math. So there you go. Lauren, if that's what you're asking on my back propagation approach, it's very simple. It's very simple. Let's see. Let's go back up here. Let's see if we get it. Okay, we got the S. All right, we did it. All right. Is it going to work this time, guys? Is it going to work? I think it's going to work. We'll find out. We'll find out if it works or not. We did it. Oh, you look. We did it. This is it right here. This is it. It looks good. Hey, look at that. We got it to work, you guys. We did the argmax. And look, you can see that it's green. So that tells you it's working. That tells you we got the green check marks. That means it's working. Not in quantum physics. Maybe in other physics, right? In other sciences, maybe you'll use some algebra there. But maybe, quantum physics, you'd probably want calculus, right? It's because you need to calculate quantums, right? Quanta. Don't you have to create little boxes? A whole bunch of little boxes is what you got to do. You quantums, because we can't measure what reality is, so we have to break it up into small parts. Do you have any opportunity for freshers in data science field? John Moen, good question. Here, I'll let you know. What we have today is, let's do PubNub, careers. This is what we have today. Let's look what we see. PubNub, jobs at PubNub. Here's my business. This is my business. We've got some jobs here. We got some jobs, some openings. We need an AI engineer. We need a reliability engineer. And we also need a solutions architect, you guys. These are what we're looking for in our job board. So just Google for PubNub careers and you will find it. Argmax Q state action value SAV SAV. Wait, what are you talking about? Argmax. Oh, Argmax. Wait, that's what we're doing. Chat GPT, you got it, Mateusz. Mateusz, you know what's going on. Mateusz. That's it, Raul. I'm a member of a community. Yes, you are. You are. Let's bring that back to let's do this real quick. We want results to be an NP array, np.array, so it looks prettier. There we go. We're going to make it pretty because we like things pretty. We did it. We made it. We made the max index value, guys. Look at that. Isn't that cool? That was like one of the things that we had to do. We were doing just this, which does a pretty good job, but this does the best. This is the best. I'm a member of your community. You are. I said hi in general chat. Oh, you did? Okay. Let's jump over here. Hey, how's it going? Okay. We got Tech. Oh, wow. We got a lot. We got Dependabot and we got Tech Pulse. Hey, Raul. Check it out. There you are. I'm Rahul from TextPulse. Oh, very cool. All right, let's go. We gotta go fire, and then a ta-da. There we go, and then we got a wave. We got a wave symbol, and then we say at TechPulse. Hello. There we go. There you go. Good to see you. Great to have you in here. Then we also got Smagus. We got a lot of joiners today. Excellent. It's great, everyone. Thank you for joining the Discord. It's great to have you all here. Okay, is this reinforcement learning RL? It is. Well, it is. It kind of is because we're giving it the right data. This is reinforcement learning. Lauren, you're right. This is reinforcement learning because we're giving it the inputs and the outputs, the expected values. So you can train data on a different how do I join the community? R7 or R7 Riz? You just click this link right here. You just click this link here. I'll paste it into chat one more time here. Check it out. I'll paste it here in one more time for chat. There you go. That's how you join the community. You did it. All you gotta do is click that button and join the Discord. That's the one. But yes, Lauren, you're right. Hey, Aziz, I am Smaggins on YouTube. Are you? Oh wait, are you really? Smagus. Oh, got it. Okay, cool. I mean Discord. I figured you meant Discord. I figured you meant Discord. Cool. So that's Aziz, Smagus. We'll say wave. Let's we'll do a fire, a party popper. We got everyone. We got all the peoples. Check it out. Smagus, welcome on in. Happy to have you. Wait, we got to also do a wave. We got to do a wave. There we go. Give you a wave there. Good to have you on Discord. Okay. So reinforcement learning, yes, is the answer. This is so cool. I'm so glad we did the max value index, you guys. We did it. It looks good. It looks very good. There we go. Okay. So that means that we're doing all the right things. Now, when I print out the screen, it will look prettier. See, now it looks prettier. Look at that. Oh, that's so much easier to read. Doesn't that look way easier to read? We can see it. And it's an argmax array. It's the argmax array. Oh, that's so cool. Oh, that's just very satisfying, isn't it? Okay. We did that. Okay. So the last thing that we're going to do today is we're going to add stochastic gradient descent into our algorithm. That's the last thing we're going to do. Basically, it means that we're going to randomize. We're going to randomize it. Right now, it's linear. We are batching, which is very necessary. You want to batch your data because you only have so much memory to hold for each of the iterations. And also, you can cause some exploding problems. So you only want a certain batch size. And so we did that, but it's not stochastic. It's not random, you guys. So what we could do is we need to randomize this, but I want to randomize it in an even distribution. So this is a challenge. This is a very big challenge. How do we even do that? So policy improvement. Improvement based on previous policy, offline, or policy improvement without a previous policy. What are you talking about? Online. What are you talking about, Lauren? What is this? What are you talking about? I'm not sure what you mean. Let me know. Let me know what you're talking about. Talking classes on RL right now. On RL. Okay, gotcha. Those are some words that you've used. What are words? I'm not exactly. I want to learn more. I want to know more. I'm curious. Let me know other details. But it's starting to click. Okay. So we've got our batching here. This is our current batching algorithm. It takes all of the epochs and then it finds all the features. And then it's reinforcement. RL is reinforcement learning. Thank you for clarifying. Taking class on reinforcement learning right now. Okay, that's what we're doing. So there's different styles of learning, right? So you've got reinforcement learning and then you've got, I guess, not reinforcement learning. What is it called when it's not RL? What is it called? What is the opposite of RL? I guess it's not reinforced, where you give it a whole bunch of data and then it can predict outcomes based on a pattern. Basically, it sees a pattern against itself, but it's not So it's like this. So you've got a whole bunch of books. You can train the model on what the next word is going to be by just feeding it all the books. But if you want to reinforce its learning, you're going to give it very specific training segments, not just books, not just broad strokes of data, but very specific sets of data. And then you can train it that way. And that is considered reinforcement, because you're reinforcing then, and you're basically optimizing it, and you're building it the way you want it, as opposed to it being just a bunch of random data. Okay. All right, here we go. So this is our current batch. What we want to do is we need, so we got our features and labels. Features and labels. We need to make sure these are aligned. Labels. These need to be aligned. How old are you? I like the way you explain and know a lot, John Moen. Thank you for asking. We have an age. We are in the age of being an adult. We have been around for a while, but I'm sure you can find out on the internet an approximate age. But for doxing purposes, we will not give away specific information on that. But thank you for asking, and also appreciate the compliment. That was a really good compliment. Thank you, John. Appreciate it. Reinforcement learning is about learning from experience. The model should figure out the right label himself. Is it? So I was saying it the wrong way around. I mean, comparing to supervised learning. Oh, so Aziz, you helped me. You helped me just now. See, we're learning together, you guys. We're learning together. Okay, so I did it the opposite. I was describing it the opposite way. So Aziz helped us out just now. So reinforcement learning versus supervised learning. Reinforcement is just, as you say, figuring it out on its own. But supervised learning is when you tell the model exactly what you want it to learn. And it sort of like over indexes on very specific things that you want it to index on. That's what it is. Zia, Fazian, I love your stream. Such motivational. That's so cool. Thank you. Appreciate it. Welcome on in. Happy to have you here. Lauren, reinforcement learning requires no data input. Wait, what do you mean no data? It has to have data input. It simply develops a policy to maximize reward now and over the course of time. This is generally defined by the Bellman equations. Is it? But wait, hold on a second. What do you mean by no data? There has to be. Are you talking about no labels? So like you've got a bunch of features, right? You've got your features, but are you talking about no labels? Is that what you're talking about? Like no labels? Like you're getting rid of the labels, but you're having only features? You got to have some data. I figure, Arxy, you're up late. Update me if so. Okay. We're at the part where we want to add stochastic. We want to add randomization to our gradient descent. That's what we want to do. And right now, it's not random. It's linear. Hacks are alive? Nah. All right. But yeah, for me, the hard part is reinforcement learning. It's the environment. Oh, Dependabot. Gotcha. There's some challenges there. Omen AI Divine. Hello, welcome on in the stream. Happy to have you here. Welcome on in. We use an MDP in RL. No data. Wait, really? Hold on a second. You're teaching me something new. Let's unsupervised learning versus reinforced learning. Yep. So we've got a whole bunch of information. Wait, let's ask the internet real quick. Okay. So supervised learning versus unsupervised learning versus reinforcement learning. It sounds like there's a whole bunch of different things here. We've got some different things. Okay, here we go. Look, we've got a diagram. Let's zoom in. Yeah, let's zoom in, you guys. Let's zoom in. Here we go. We're zoomed in. All right, so supervised, unsupervised reinforcements. Okay, there's different kinds of learning we got here. All right, so supervised, you got data with labels. That means supervised. So you've got the full data set. You've got all the pictures, the full picture. Unsupervised, data without labels. Okay, so, and then reinforcement, state plus actions. So which one is good for chess? Like if you were going to train on chess, which one of these approaches would you use? Supervised, unsupervised, or reinforcement learning, or all of the above? We're testing you now, chat. We're testing you. We're testing you now. Which one is it? Actually, let's find out. Let's see if we can figure it out. In RL, you don't need a data set, only need an environment to interact and learn. You make a reward and, okay, dependabot. There we go. So maybe, is that what chess is? Is that what chess is? There's some rules. So you want to use reinforcement learning, and that's a really good way to do some chess. Is that what you mean? The model is basically interacting. Yep. If it makes mistakes, I guess it will learn from that. Yep, that makes sense. So chess then, I guess, is reinforcement learning. Supervised learning uses labeled data to predict outcomes. Unsupervised learning finds patterns in unlabeled data, and reinforcement learning uses trial and error with rewards to teach agents to make sequential decisions in an environment. So there you go. There's how to. So you could teach an AI model with reinforcement learning to learn chess. I think that makes sense. So for chess, let's see if we're right. Let's see if we're right. We'll ask the AI. We'll go into AI mode. So for chess, training AI on chess would be RL. Let's see if it gets it. I'm pretty sure. Is that what it is? Yes, it is reinforcement learning. There we go. We got the answer. It was C. It was C all along. King George, welcome on in. Hello again. Happy to have you here. Reinforcement learning is good for chess in the long run. Lauren, good to hear. We just used the model. Whatever action was good or not, that's the way to do it. Basically, that's the way. Just finished these topics today. Muhammad, we're learning together. We're learning all together, you guys. AlphaZero, for instance, used this approach for superhuman performance in chess, playing millions of games against itself and learning through trial and error. Reinforcement learning, you guys. That's the way to do it. Without any labels or features, it is presented a world with rules in which it learns to, I guess, make chess moves. Would Markov hidden states be good way to train a model to win at chess? I don't actually know. Would let's do this. Markov's hidden states be good at training chess? Winning. Okay. Winning. There we go. Thank you for likes, you guys. I've tried using RL for tic-tac-toe agent. You did? Did it work really well? Let's find out. While Markov models are their extension of a hidden HMMs are fundamental used in reckonings, they are generally not the primary most effective method for direct training an AI to win chess. So in this case, hidden Markov is not generally the primarily most effective way to do it. Basically, it's saying nice. It's like, nope, you don't need to do it. You don't need an HMM. You don't need an HMM. You don't. The math behind it is fantastic too. Is it? Not exactly. Chess doesn't flow in Markov properly. Oh, property. Got it, Erwin. Thank you so much, Merwin Deep. All right, let's see if did we get all the chat messages? I think we did. Let's see if we can get back to our algorithm here. All right, the last thing we have to do today before we end stream is, you got it, Raul? We got it. We need to add some randomness to this. Jake chess mate soon to win as fast. You got it. Alvaro, that's what we got to do. That would actually be a lot of fun, building a reinforcement learning algorithm to win at chess. We could totally do it. We can make it happen. Okay, so right now we're trying to do something a little bit more simple. HMMs are good for back test optimizations. Oh, are they? Okay. Back test optimizations. Good to know, Raul. What we have to do here is add some randomness. So we could, how do we want to do this? Okay, so inputs and targets. So what we could do is we can't do that. I'm trying to think of like a really good way to make this happen. So we've got our primary features and labels for every epoch. Okay, so this is going to be the full data set plus the epoch, but I need to randomize it. So here's the features and labels. And basically, if I add some random data here, some random indexing here, it might work. What is backtest? I'm thinking is talking about back propagation. Is that what you're talking about, Raul? Is back propagation? I think that might be what it is. For backtesting might be back propagation. I think so. It might be. Or it could be a separate thing. It could be something completely new that I'm not familiar with. Raul, please do something on stock trading algorithm one day if you haven't already. Okay, Raul, we're going to add it. We'll make it. I've actually done it before. Okay, so future stream idea, you guys. Let's zoom in. Let's zoom in. All right, let's zoom in here. All right, future stream idea. Let me kind of, there we go. The triples there. Future stream idea. We'll do, what do you call it? Stock trading AI algorithm, and we will make a very good one. We'll make one that exceeds market expectations. You'd be like, Steven, if you can already do that, why wouldn't you make all the money you possibly could? Because I'm doing other things, you guys. I'm doing other things. I don't need to, but trading, is it, how do you say trading? Is that how you spell trading? Is this it? With 2Ds? No? Trade? Stock trade AI algorithm. Perfect. That's the stuff we're gonna do that. 1 2 3. There we go. Perfect. All right. Boom. We did it. All right. Future stream idea. Stock trade AI algorithm. We can do it, you guys. Subscribed, Gabriel. Thank you, Gabriella. Happy to have you in. Thank you for subscribing. We'll be doing some future stock streams with AI trading algorithm. That's what we're going to do in the future. Stock trading backtesting. That's it, Raul. By the way, you're currently training an agent to play Pong game in real with reinforcement learning, and it's been 2 hours now. Really, Aziz? That is cool. That's really cool. That's amazing. Trading, yeah. We will be able to do it, and it will work really well. It works very well, and you'll be able to actually make money on the algorithm. See, the problem is, though, you'll have to do short-term capital gains, and there's other approaches to deal with this scenario. So but if you want, we can profit together, you guys. We'll profit together, but I'll be a future stream. That's a future stream trading. Future stream trading. Okay, let's add some randomness. Let's do this. Okay. So we've got our features, labels, and targets, but I want to go further. I want to take the entire data set and then append. So we need to create a batch for each range. Okay, so for number of batch size, so we got epochs, and then our features divided the batch. This will give us the number of batches that we want and the number of epochs all together, basically. So epochs and batches. Aziz, that's amazing. Trading true, false, identify, real, win. You got it. Yes, that's it. That's what we got to do. We got to do that. Okay. But what I got to do now is figure out how to do this randomness. So we've got our inputs and targets, which are features and labels, right? We've got our features and labels right here, features and labels. But I want to add some randomness to this. How do we do this? Alvaro, hit me up on Discord, Raul. That's what Raul's asking. You will be able to this. Aziz, I will share the code if you are interested. Very cool, you guys. All right. Let's see here. How do we add in random? I want to add some randomness to this. So what we could do is we need a random number between. So we could shuffle, but I want to do a full shuffle, like a complete shuffle across the entire features and labels. So a complete shuffle, not just a shuffle in the batch, but a shuffle. I love this community. Yes, Aziz, I'm in. New on Discord. Excellent. That's so cool. We're here. We're going to make it happen, you guys. It's going to be before this loop, create a list of indices for a batch starting points. That's a really good idea. That's what we should do. Okay. So we could do that. So let's see if let's do that. So can we get input? Let's do what we'll do is we'll do a full copy inputs and targets, and we'll do a full copy. We'll do a full copy like this, but we will do it based on all existing features. But we won't do it on the range. We need to do it on the feature. But here's the thing: when we create the random number, we need to do it in a way that So we need the full data set size, which is the length of the features. Okay. There we go. Thank you for the likes, you guys. Yeah, it's cool energy. That's what we need. That's what we need, you guys. That's definitely what we need. Okay, so here is the entire size of the array, both features and targets, features and labels. And then we need, so we can do, there's an np.random, np.rand. How do we do this? No, but it's got to be uniform. It's got to do. Maybe we can check this. Let's try that. I think we've come up with an option. Python import numpy as np, np.rand. let's see, np.rand. Is it random? Okay. Wait, it is a module. Okay, we got is a module dot uniform, I think, right? And let's see here. We'll go 0, 1 to 3. Let's see what that does. Oh, no. That's just, let's see, can we do, what does that do? Okay, that makes an array, but that is going to create, let's see, it's 10. Okay, so it makes 10 of them. So let's say 1 to, let's see, 1 to 10, right? But uniform, how do we do a uniform integer, right? Make them integers. How do we make uniform, is it uniform I? No, uniform X maybe? No, let's see. Let's do this. Dir. Okay, look for uniform. So uniform. It's just one uniform. There's only one uniform, you guys. So let's see. How true? Or something like that. Oh, not uniform X. Okay. Uniform like that. No. Name true. Wait. TRUE. No, it doesn't like that. It doesn't like that. I want these to be not floating point numbers. So I guess we could do int, something like that. It doesn't like that. How do we do this? Divide by 10. So that does not work. 1. Okay, that works. That kind of works. This actually is a really good, I think this is it right here. Rand int. Yes, that's what we want. We want rand int. Oh, but it needs to be a uniform, right? It needs to be uniform. So here's the idea between uniform. It's going to, but also at the same time, it's not quite giving me what I want is a perfect array. Okay. I need to shuffle. Okay. This is what we need to do. I think I figured it out. Okay. So we've got a range. Say we've got 10 things here. Is it X range? No, we don't have X range there. So we'll do X for X in like that. So there's a full range, and then we say A equals, right? And we say A dot shuffle. Is that a function? It's not a function. There's no, but maybe NumPy, right? Maybe NumPy has that. Maybe NumPy has a shuffle. NP dot array. Let's see here. There we go. A. So A, right? A dot shuffle. It is does not have an attribute shuffle. Dir A. We'll look up on the internet here pretty soon. Is there any sort of shuffling that we can get here? Shuffle. There is a shuffle here. Where is that? Oh, in random. Oh, np.random.shuffle. Okay. np.random.shuffle is a method. Okay. A. Perfect. Okay, this is it. This is what we need. We got it. We got what we needed. Yeah, shuffle about 30% of the total. So, random.permutation. Use random.permutation. Okay, let's try that. I want to see if maybe that gives us something better. np.random.permutation is a method. All right. 1, 10. Let's see what that does. 1 and 10. Permutation only. Okay, so let's do 10. Oh, this is it. This is way better. Permutation. So now we can do it all in one call. Thank you. See, we're coming up with all. Thank you, chat. Thank you, Erwin Deep. Thank you. You knew exactly what I wanted. This is what I wanted right here. Okay. This is what we're looking for. This is it right here. So now we can, this is critical because what we need is, in order to properly get the alignment, so for the inputs and targets, we need to create our own dedicated, and then we'll batch them up here later. We'll batch them up in a second. Sick, excellent. By the way, I've been my own reinforcement learning trading framework, really with Q learning, SARSA, and greedy GQ agents. That's Raul. You're doing something interesting. That sounds amazing. I would actually like to learn more about that. What is that? Alvaro says, cool. Raul, I'll share the GitHub link in Discord. That would be so cool. Thank you for doing that. It uses scikit-learn, but wanted to have a go with creating your own framework. That's what we're doing here. We're creating our own framework from scratch. And then we're implementing our own algorithms. And I wanted to add just this last bit here. So we have this. Now we have our full, and then we want to do this based on the length, right? So we got len. There we go. Like that. Let's double check. I'm pretty sure I'm pretty sure that'll do the trick. I'm pretty sure that does the trick. So now what this is, it gets us for every epoch, we want to readjust the random, but then it gives a full. So where do you get that energy? Atlas 3? Wait, what? Wait, what do you mean Atlesia 3? What is that? Atlesia. What is Atlesia? What is Atlesia? What are you talking about? We're talking about. But if you want to talk about energy, here is your answer. The answer is eat food properly. Eat food properly. I've got your answer right here. I know I've got it in here. Here we go. Eat food properly, you guys. That's breakfast. You got to eat food properly, and then that's lunch, and then that's also dinner. Make sure you eat properly. That's the answer. That's how to eat. I made a video on how to eat properly. I think the video is in here pretty somewhere. New videos. Yeah, here we go. Yeah, it was a video on eating properly. It's around here somewhere. Here we go. It basically is saying that eating properly, and then you got unlimited energy. You don't even need any sort of other stimulants. You're good to go. All right, this is the critical part. Love this content. Cool, Avro. Thank you so much. Happy to hear it. Really good feedback. This helps me a lot. Thank you so much. Okay. NP, we're happy here. We got it. We're really good to go. This means this is our what do we call this? TR? Well, I guess we call this stochastic. We'll call this our stochastic. Stochastic? Is that how we spelled stochastic? I want to double check because I'm always interested. Is that it? Is we spelled it correctly? Oh, look at this. I never spell things correctly. I hardly ever spell things correctly. So this is our stochastic data. And then we do input target, and then we will do, what is this? Self-dot backward. But this will do it for a batch. Okay, so that's one batch. We now what we need to do is inputs and targets, and then we need to create this, and then we need to do another batch. So inputs and targets. Here we go, like this, like that. But instead of, we'll say input and target like that, so that way we have the right information. Okay, perfect. Okay. And then we'll do this, and we'll do something like this. Stochastic. Stochastic. Did we do it right? Stochastic. Yeah, we got it. What is Atlas 3 though? Yeah, that's what I'm wondering. What is Atlas 3? I posted a link. This was a private until this morning. Really, I made it public to contribute to the amazing community. Okay, let's check it out. Okay, general chat. Let's zoom out a little bit. Here we go. Tech Pulse Raul. All right, let's check this out. What do we got? Whoa, you've got a lot of folders there. You've been busy. William McGarth, new to the stream. What are we coding? We're updating our from scratch, our own deep learning neural network that we built from scratch live on stream in previous streams. We made it good, and now we're making it better. So here's the important parts of the algorithm, and now we're adding some randomness so we can have full SGD. We want full SGD, stochastic gradient descent. But first, before we do that, we're checking out an RL trading bot that Raul gave us. Actually, Raul and TechPulse gave us over here. Let's check it out really quick. This looks very much like did an AI write this? I'm just wondering, because an AI did write this, didn't it? Raul, hold on a second. I think an AI wrote this. I'm suspicious. But hey, you know what? It actually doesn't matter because it's okay. We're expecting to use AI these days. William McGarth, happy to have you in here. Let me know if you want to have any details described. But it's good to use AI. You're doing it properly. Even if you did, but it very much looks like you. I'm pretty sure you used AI. I'm pretty sure. RL Trader, okay, QLearn, SRM. Grunge 710. Are you programming your LLM to have the highest score as its goal for learning? Riz7, I know. R7, isn't it crazy? I'm pretty sure. Looks AI written, doesn't it? You can tell. There's little giveaways, you guys. Oh, you've got a YAML file. This is cool. So I don't training the LLM to have the highest score and goal for learning. Basically, yeah. I mean, basically that's what we're doing. Basically, that is essentially basically. Well, yeah, it iterated the README files and documents because I'm a new developer. Okay, gotcha. Understood. So, yep, you're admitting to it. You admitted to it. Okay, but actually it's fine. You're actually doing good. You're doing the right thing. You're using modern technologies and modern tools to make things faster and better. So, Raul, this is good. This is good news. You're doing it right. This is the right way. In fact, if you did this all by hand, I mean, I would also question that. I'm like, and I would say it the other way around. I'd be like, why haven't you used AI? Like, what are you doing? Why are you not using AI? In fact, I would question you. Well, if AI is trained to get the highest score in previous simulations, is it shows that eventually the AI learns that the way to get the highest score is to cheat, and it will get better at it. It will be really good at cheating. I mean, basically, that's what we're doing here. You want, in order to win, you can cheat. You can exceed the rules, and you can cheat. I use Claude. Yeah, this definitely looks like Claude code. It looks like Claude code. I'm 2 months into my journey. Very nice. You're doing it properly. This is the right way to do it. You're doing it properly. All right, let's check it. Take a look. There's too many files to go through. I definitely will not have any time to go through this. Is there any one file that looks like it's interesting? I see a folder here called train, stress, sweep, train, quantum blend. What? Wait, here's train.rl. I think this one looks good. Make agent. Okay. Agent name, Q learning agent. Whoa, what's this? What is this? What are these? Where is that? What's going on here? NumPy pandas? Okay. Greedy Q agent. Okay. Interesting. I have no idea what's going on here. Okay, so you've got some gamma, beta, alpha, epsilons, EPSs, lambdas. What do you do? What is this? What's happening? Train size. Train split. Okay, so the splitting, I know what that is. That's easy. How do you want to split your data between training data and the testing data? And then here you go. Your training index. Okay, looks good. Trading environment. All right. There's a lot to go through here. There's way too much. What is going? This is like a little bit complex. This is a little bit much. I'm actually really curious to see what the results are from this. This is a bit much. Early warning checks after learning step. For what? What are you checking for? Are you testing the model? Check TD error TD error. What is TD error? What is TD error? 710. Do you think cheating AI affects its overall effective nature? If it wins, well, here's the deal. You want to have a dedicated AI to learn the best it possibly can for every possible scenario and situation that you're dedicating it to. And if it can cheat and win and be successful, you might as well, but you don't want to use that same cheating AI for something else. Thank you for the likes, you guys. It uses safe protocol, Raul. Okay, safe protocol. Got it. I have no idea what that is. I don't know what that is. What is safe protocol? I don't know what that is. Early warning summary. Interesting. Total warnings. Oh. Okay. I don't know. I don't get it. But I am, if W is none, weights norms. Okay. All right. Okay. So this is not a deep learning model. It looks kind of like a linear regression. A little bit, but RL trading agents. Interesting. This is very interesting. New here. What are we doing? TMW Wrestling 1996. Welcome on in. We are building our own machine learning neural network. It's a deep learning model from scratch. We were successful on previous streams. We did it. We got it working, and now we're just making improvements. But right now, really quick, we had Raul, who is our Tech Pulse here in our Discord channel. And our Discord channel, Tech Pulse, gave us some code. We got some code here. Rajesh War, hello. Welcome on in. Happy to have you here. We're looking through some AI code. We're looking at some coding that does some. This is a trading bot that Rahul gave us. Rahul gave it to us. Get God 82. All right. Reinforcement learning training framework with Q learning, SARS, and greedy QA agents. All right. Check the README. It shows how you use it in a simplified way. Okay. Let's see. All right. So pip install. Interesting. A wheel. Whoa. This is weird. RO Trader wheel. Download the wheel. Okay. Pip install directly from Git. Cool. That's option 2. All right. Quick usage. Set it to the answer of life. All right. 42. Very nice. Config. Okay. So you got your config file, which was here. So here's our config file. And what are all these variables? I do not know. These are just basic stand-in variables. Decay and other things. Okay. All right. Let's see here. Set the seed to 42. Environment equals trading environment, which is your config data. Agent. Q learning. Okay. Observe. OBS. env reset. Episode in range 100. Is this, I suppose you're going to train 100 times. So that's the epoch. Number of episodes. Action. OBS reward done info. So you're going to step forward and then you're going to update. So that's the training. And then you check if it's done. Okay. That makes a lot of sense. Hello, bro. Welcome on in. Happy to have you. Happy to have you here. Thank you so much for joining in. Erwind, these help with explorations versus exploitation. Exploitation versus exploration. These, I don't know. Between the two, and maybe both at the same time. So, Ro, this is really cool. This is really neat. We'll have to check it out a little bit more deep, maybe off stream. I'll have to check it off stream. So I do have to get going here. But before we go, we have one last task that I would love to finish. Our randomized deep learning data. I want to finish that really quick before we get any further. Before we go, this is the one thing I want to do before we end stream. We have to get this one part here. So we got our random data. We got a random dictionary. And then, so we can create a range and the same kind of range here, like this, inputs. And then we're going to use stochastic. So we say I for I in, like this. And then we do our stochastic, like this, right? So you go stochastic, like that. And this gets us the value. And then we get our features. And then we go like this, like this. There we go. And we're like that. There we go. Now we got our input data. Then we can do the same thing for the targets, like this. There we go. And then we can also grab the labels like this. There we go. And now what we've done is we've randomized it. You guys. There we go. And then we need to change it. So we go for I in epochs. Here we go. This is the last thing we got to do before we go offline. So for every epoch, I want to re-randomize and reshuffle. Okay. And now we're going to do another. This indentation is a little bit much. I don't like to indent this much, so I'm doing some craziness here. But we do need the number of batches. How many batches is going to be the full data set? Is going to be the full. You don't need inputs and targets. These are redundant now. They sort of. Well, actually, you're right. You're totally right. So what we have to do is we need to grab the batch. So we need to make a batch. So what we need to do is inputs and targets. So we have to do it like this. Target input. Here we go. So actually, this is the batch, right? Because we're going to do one batch at a time. And so we also need to update this segment here to get the right number of iterations. So we need total. Basically, I think it's this. I think it looks like that. That's what it looks like. Okay. So number of features. Divided the number of the batches. And so this will give us the number of times to loop through the batches. So we get all the batches. And then we need I colon. So what is this? I times, or we'll figure this out. Okay. We need to capture just segments of it, right? Because we've got the inputs and targets. Now we just want to take we need to chunk through it in sizes of the the batch. So batch, BATCH, and I believe it will be I batch. So here for I and we're almost there, you guys. We're almost there, and then we'll be able to do the same thing down here in the targets as well, like that. But targets, perfect. Okay, nearly there. Okay, so this is not complete, but this is going to give us one batch. But it needs to be, I times batch, and then I times batch plus batch, I think. Plus batch, like this. Is this it? Is this right here? Did we get it right? I think this is it, you guys. Chat, I think this is right. It looks a little bit much, and I don't like how advanced it looks because it's really difficult to read. It is very difficult to read. Here, let me separate this. Let's separate that, and we'll separate that so it's a little bit easier to read. Just a smidgen. Actually, we'll put spaces here too. We'll just put spaces like that, and we'll do the same thing over here. We'll just spaces everywhere, you guys. Spaces everywhere. Make it just slightly easier to read. Okay. And then we will add this so it looks like that, like this and that. Perfect. Okay. So it's going to be 0, right? It's going to start with 0. So start with 0. And then we have 0 plus batch. So this will get its first batch all the way to the end. And now what we've done is we've created a random dictionary with this random permutation, which looks like this. So kind of like this. And then we'll always reshuffle that every time. And then we're going to take slices of that data. We'll take slices of it. Some slices based on the shuffle, right? So based on the shuffle. Or do we need to do this? Can we simplify it even further? Do we need to do it like this? Do we need to take slices? Can't we just use the stochastic pointer and then go for it from there? Do we need to go all the way, like creating brand new dictionaries? We might not need to. This is my first ever Git project. It was for the love. Haha. It was okay. Really good Git project. That was huge Git project. If it's really bad, please don't mock me. Hey, don't worry. It all looks good. We'll have to check it out a little bit more. I think you did really good. So here's the parts that I like. There are some actual problems here. So problem number 1, it is very complex for what it is. That is problem number 1, which is a really big problem. So there's a lot going on. There's just a ton going on. What's great is it looks like it's simple to use. I really like how easy it is to use. So this is some feedback. I like how it straightforward, looks simple. I like it. But I don't know how. I know how to run some data, like I know how to deal with this, but I'm not exactly sure where the input data is and where the output is. So I'm missing some details here. Like I don't know what to do from there. And then like what's going on? Like it's just a little too complicated. I like simplicity. All right, training different agents. So you can load some data, sample data. Okay, here we go. So this is just further down in. We're looking good here. QA agent, train once. Okay, greedy. Okay. Custom backtesting. Okay, got it. So backtesting is different than back propagation in this case. There you go. That's what we need to know. And then, okay, so then you provide some common commands. Check the backtest part just below. Okay, here we go. Custom backtesting. From backtest, agent trained, lambda, build. Okay. Backtest stats, run BT. And then you print stats. Okay, so this must give us the performance or how well the model performed, how well it did. I think that's the answer. So that's actually pretty clean, but the worst, so that's all good. Like that's the best part. The utility and being able to leverage it, it looks good. There is a lot of details. It's kind of complicated, and there's just a lot to it. And there's a lot, just like a ton. And there's a lot of files. So there's just a ton of stuff in here. And it might be that a lot of it's not related, or it is in some other way and it's not used, but there's just a lot of things happening here. There's just a lot. And so that makes it a little bit of a challenge for maintenance and code ownership going forward. That's some of the problems. Okay, so I am almost out of time. I do have to get going. I have like a couple minutes left. Then I have to go. But before that happens, we have to finish our data here. So I think we can improve it further, but this should actually work. Let's actually just run it and see if it works. Let's see if it works, you guys. I'm actually kind of curious. Oh yeah, of course. We have some stuff here. We got to take care of that. Okay. Is it going to work? Is it going to work? Oh, we got a problem. Local variable inputs reference before assignment. Okay, inputs. Forward inputs. Oh, there it is. Thank you. Thank you for the likes, you guys. We got to call it features. Features. Here we go. There you go. Thank you for the likes. Jude, how's it going, Jude? Happy to have you in. Bro, I accidentally pushed my whole project when I did the git push and I need to clean things up. Okay. That helps. That describes it. So that helps understanding it a little bit better. There we go. Describe it a little bit better. Raul, thank you. Tech Pulse. Okay. Here we go. Here we go, you guys. Let's see. If we get it working, we did it. And then we'll have to, next stream, we'll have to update it. Oh, int object is not iterable. 1 second. 1 second. Where's int? Int at. Oh, here. Range int. Yeah, it is. Oh, is it though? Maybe we don't need int. Maybe we don't need int there. Let's see. Like that. Can we get away with it like this? Is this good? I don't know. We're going to find out. Is it iterable in this case, or are we going to have another error? Int object is not iterable. Uh-oh. We've got a problem, you guys. We got a problem. Where is it? On line 101? Oh, 101 epochs. Epochs. Wait, what do you mean it's not iterable? 101 is not iterable? Int object is not iterable. For I in epochs. It's totally iterable. What is it talking about? Why did it say that? What does chat, do you know? Do you know, chat? What's wrong with this? I mean, it looks perfectly fine here, right? So you got that, and then you've got this over here as well. It looks fine to me. Right here, it looks totally fine. Epochs is 10. That's an iterable value. That is totally an iterable value. Are you using a smear cursor? I am using Tmux. Animation on mine is pixelated. Is it? Actually, I don't know. Range epochs. Range. Oh, range epochs? But it's an... Oh, you're right. You are right. You are so smart. Thank you, Erwin Deep. Sounds like that's what it is. Chat, you win again. You win again, chat. Good job. This is it. This is the answer. Oh, thank you. Erwin Deep, you're a lifesaver. Thank you. Thank you so much, Dr. Zed. Okay, we got another problem. We'll fix that in a bit. If only you had a strong typed language. Instead, you're using hideous Python. Hey, Dr. Zed, Python is used for the most prominent data science tech in the world. A proper compiler would tell you the issue immediately. You're totally right. This is why at my company, our infrastructure, we migrated all of our code to Rust. It is a strongly typed language, and a very strict compiler. We've migrated all of our code to Rust, and it is beautiful. Buddy, I'm a #1 top Python deep learning programmer working for both Google and Apple, ex-Microsoft employee, 1000%, Tenji. Are you really, Tenji? Just do what I do. Use C to make an LLM. Yeah, if you want the fastest, I actually recommend Rust. Rust would probably be the best. Rust. Yes, use Rust, you guys. Use Rust. Better than C. What distro do you use? SAQ. SAQ, this is Mac OS. We're running Mac OS. It looks like it's Linux because it's a Unix-based system. Unix, but just running in a terminal window. Okay, let's see where this thing is. Inputs. Oh, but we did inputs for inputs. Inputs. Oh, inputs. Link inputs. Okay. So this needs to be features, right? No, this needs to be something else. Oh, I forgot. We have to fix this. We never fixed this. This is something that we have to fix. So we've got our stochastic, and then we're going to do a full shuffle, and this has to be features, and this could be labels. Labels. There we go. There we go, you guys. If I wanted Rust, I'd have WD-40 with me. Tengi, wait, WD-40, are you talking about the lubricant? You're talking about the lubricant spray? Is that what you're talking about? Why would you bring WD-40 to a programming language? Just use inputs equals stochastic. See, would that work? Wait, does that work? Can you do that? Wait, Erwin Deep, can you do that? Is that something you can do? Hold on. I want to see that. I want to see if that's something you can do. Okay. So go here. Let's do this. Copy and paste this really quick. Import numpy as np. And we're going to go like this. We'll go a equals, and then we'll do like 10, right? 10, something like that. So we got a nice array like that. And then you said features and like that. So you're saying I can do this? Oh my gosh. Oh my gosh. Wait, really? Seriously? Wait, does that work? I never knew that you could do that. Are you serious? Wait. Seriously? No way. No way. No way. Whoa, look at that. Oh my, that is amazing. Okay. Dude, Erwin Deep, you just made everything better. You made it way better. Look at what we're doing. We're like trying to, we're going over here. we're just trying, but you could do it. Wait, like this, right? Dot, 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 like that, dot, like this, like that. There you go. Check it out. Let me just copy and paste this, like this. Womp, womp, womp. Let me go over here, targets, like that. Boom. Is this it? Whoa, that is so cool. I didn't know you could do that. Oh, wait, WD-40 is 1,000 for the keyboard, Windows, Microsoft. Is that what that is? Erwin Deep, wow. That is some really cool shorthand notation that is absolutely beautiful. Thank you so much. Also do this before the loop. But I want to reshuffle every single epoch, right? Because we're doing stochastic. So we could, I want to reshuffle every epoch is what I want to do, right? Yes. Anyone here using Windows? You got someone. Thank you for the likes, you guys. Erwin Deep is a legend. You are the legend. Thank you. You just turned a whole bunch of complicated code. See, this is what I like. I like simplicity. Very good. Very good. Simplicity. I missed that from the shorthand. Me too, Ben T. Me too. Then put stochastic in the loop. Oh, yeah. Okay, thank you. You're right. For every epoch, we need to reshuffle it. You're right. Thank you. Perfect. So this gives us our stochastic, right? Our random. This should be it. I think this is it. Can we make this look pretty too? Let me know if we can make this look pretty too. All right, let's run it. Let's see if it works. All right. See Python ml.py. Here we go. Is it going to work? Need to coach. Oh, it's working. Oh, we did it. Look, you guys. They're all green check marks. They're all green. We did it. Oh, it's so cool. We did it. They're all green. Every single one of them is green. It's the thing that we wanted. We need to make some coaching from Erwin Deep. We do. Chat, you guys did it. This is so cool. Your name must be Arc used, by the way. There we go. Wow, Arky, damn, I know. Look at that. Every single check mark is green. Did you know you could do that? Did you know? Look how powerful this updated algorithm is, because it was like 98%. Now it's 100%, you guys. It's 100%. Look at that. Right there. They're all green. All the check marks are green. That's so cool. Oh, we did it. Everyone. Check this out. Look at all those beautiful green check marks right here. Oh, so good right here. Ooh, that's it. We did it. We achieved the objective. All right, now let's commit and push to production. That's what we got to do. Git status, git add ml, .py, git commit -m. Guess what? We did it with the help, with help from a Rajesh War. Wait, no, not Rajesh. Wait. I guess I got wait. Erwin Deep. Sorry, I gotta put your name right. Thank you. We did it to make it really cool. All right, git push origin main. Boom, it's live now. Steven, what does your code do? I mean, what is your goal? SAQ? So the main goal was to do stochastic gradient descent today, but we built our own machine learning language from scratch, or model from scratch, right? So we got our algorithm here at the bottom of the screen, which is the main part of it. And we want, I guess the idea is to use it for general purpose AI utilities, right? For general purpose AI. And someone else from chat in a previous stream was like, hey, why don't you train it on the MNIST data set? And so that's what we did. We trained it on computer vision. So it's a computer vision model. It's able to do OCR, which is a OCR meaning. OCR. What is OCR? It is short optical character recognition. We did optical character recognition, you guys. That's what it is. And that's what we did. And that's why all these green check marks are showing up right here. Isn't that cool? All these beautiful green check marks right here on the screen. That means it got all the characters correct, you guys. And we did it. We did OCR for the MNIST dataset. The MNIST dataset, and it looks like this. A whole bunch of numbers, as you can see here on the screen. A whole bunch of handwritten numbers. That's what we did. Optical character recognition. Congratulations. I know, very awesome. And it was all from our own. You had a Google OCR. I know. No. I know, LJ23. I know. I'm just so... It's late. We had a lot of fun. We were doing a lot of things. We've been streaming here for quite a while. I know I had to go, but we did it, you guys. We did it. We made our own OCR program from scratch for the most part. Because we're using NumPy. We're using NumPy, you guys. We're using NumPy. We did it. Do you do ethical hacking? Yes. So like Metasploit and what is that? There's like a really Kylie Linux. What is it? Something. There's a Linux distro. It's 8:30 a.m. in Australia. Well, it is 5:30 p.m. here in Seattle, Washington, where I live. Rajeshwar, hearts. Thank you guys for the likes. Appreciate it. So we do have to get going. Thank you so much for everyone for joining. We'll be live on Monday. We'll go live again on Monday. We'll be back on Monday, you guys. We will be doing more AI, or maybe we'll do some assembly. Kali Linux. Yep, that's what it is. Kali Linux. Thank you. Backtrack. Wait, what do we backtrack? We will be doing some other things. What is the future? What are we doing? So we go live Monday through Friday. Different times in the day. So subscribe to get the notification. I'll try to go live throughout different times of the day. What is this? Zahir. We're a computer science, AI, deep learning, data science, cryptography, security. We do it all. We do everything, because I've got this company that I've owned that has taught me a lot of technology over the years, and I'm teaching it back to the community. So subscribe if you want to see when we go live next. Backtrack was the old name for Kali Linux. Oh, was it? It's called Backtrack. Stock trading algorithm. We will do it. I will show you how to build the best stock trading algorithm that I currently understand as the best. We will do it. It is really cool. And we can, I've actually done it, and I got like really good results, but I don't actually utilize it because it is all consuming, you guys. If you do your own trading algorithms and you run them using your own real money, it's all consuming, and it's the only thing you care about, and it takes all your aspirations and ambitions away. So I stopped doing it because it was too consuming. I had other things to focus on, so I stopped doing it. But I will give you all the ideas that I've come up with over the years. Kali Linux, Parrot OS, and Black Arc. These are the different Linux distributions that you could use for ethical hacking, you guys. We'll be doing some other things like that. Will it do? Excellent. That sounds good to me. So we're headed out, you guys. Thank you so much for hanging out with us. Join our Discord too if you want to join the community. Stock trading algorithm is what we're going to do. That's my ASL. That's your ASL. Here, I'll paste the Discord one more time if you guys are interested in joining the community. Join the community, you guys. We'll be live on Monday. So we'll be live next week. In 2 days, it'll be aspiration to do algorithmic trading full time. You can do it. You can totally do it, and you can make a living do it. And it's actually really good. Here's the deal. Raul, just to let you know, algorithmic trading helps everyone. Not just you. Yes, you are going to profit, but it helps the entire market as well. We want day traders. We like them. They're not stealing from anyone. They're contributing. It's a contribution. It's actually a really beneficial community member in the finance industry to be a day trader. You can do it, and you can trade algorithmically. You can do it. You can be your own quant. You can be a quant, you guys. Aspirations, you got it. Awesome video pace. Thank you so much, everyone. Discord and Havoc lately, by the way. Excellent. You was Havoc. You are Havoc lately, by the way. Okay, Havoc. We'll look for you in Discord called Havoc. Thank you. Hey, Akash, we're just headed out now, you guys. We're Akash. 1 terabyte data leaked. Oh, that's a lot of terabytes. That's a lot of data. Amazing. This is very inspiring, Ro. Happy to do it. Great to hear. is going to be leaked. Oh, is going to be leaked. Okay. Soon. SAQ, soon. All right. So join the Discord or subscribe. We'll be back on Monday. We'll be doing more artificial intelligence. SAQ hacked. Sad face. Oh, no. I want to automate the pivots. You do the pivot tables. You want to automate the pivot tables. Your spreadsheets, you can totally do that too. You can totally do it. Not another leak. I know. It's crazy. So many leaks, you guys. It's crazy. Thank you, everyone, for joining. We're going to click the stop stream button now. It was great to have everyone here. We're going to stop. We're done for the day. We'll be back on Monday. Everyone. Have a great weekend. We'll see you guys next week. Don't leak it. Don't do it. SAQ, don't do it. Or if you want, you can. You can totally do it. 1 terabyte's a lot of data. Thank you for the likes, you guys. What does this code do? Don Menendez. Mendoza. Don Mendoza. It does anything we want it to do. It does all the things. Discord was hacked lately. 1 terabyte will be leaked. Uh-oh. That means all of our data. We're all leaked, you guys. It's too late now. Discord. Oh, that's terrible. Yep. See you too. Cool. Bye, everyone. See you on Monday. We'll be back on Monday. Bye, everyone. I'm clicking the end stream button now. See you Monday.